Hello guys, welcome back to my channel. In this video, we will be talking about memory allocation for objects. As you can see here, this is a graph which shows how memory is stored for classes. So let us consider an example. We have a class, and inside the class we have function 1, function 2 and function 3. Then we have data member 1, data member 2, which are the variables. Okay, so in this case, when we declare a class like that, the memory for functions are stored, which is common for all the objects. And for objects, each of the variables are different. That is, for each object, there will be a different variable stored for them. But in the case of functions, functions is common for all the objects. So what is private space for member variables? Object is a combination of one or more variables declared inside the class. Each variable has its own copy of public and private data members. An object has access to its own copy of data members and has no access to data members of the other objects. I hope you understood. Now here we have a class inside which we have public index and y. After that, we are declaring two objects of obj1 and obj2. And for obj1.x, we are giving a value of 20, and obj2.x, we are giving a value of 40. So, as you can see here from this pictorial representation, we have obj1 and obj2. So, the value of x here will be 20, and the value of x here will be 40. So the values are differently stored, and we can't access the data members of the other objects. So the obj1 cannot access the data members of obj2 and vice versa. So what are the common area for member functions? Member functions are created and placed in the memory only once when they are defined as a part of class specification. No separate space is allocated to member functions when objects are created. All objects of the class use same area for member functions. Space for member variables will be allocated separately for different objects, and they can hold different data values. So predict the output. We have a class named data which has data members which are integer I, float j, double d, and we have a public function which is get data. So it inputs the value of I, j, and d. Then in the main function we have two objects d1 and d2 of class data, and we have cout. So in the first case we are printing the size of d1, that is the size of the object d1. So the size of the object d1 will be the sum of the memory of each of the data members in that object, and similarly size of d2 will be the sum of the data members in that object. Then we have size of data, that is the size of the complete data, and that is all. So in all these cases, we'll get the same value because the address stored or the memory stored is only for the variables, and for functions there is none. Now let us have a uh, overview of what is the difference between static variables and non-static variables. As you can see here, we have hash include stdio.h. Then we have a function which is static in count 0, count plus plus return count. Then we have another program which doesn't have static in front of the variable. So what will be the case for the cases? So let us consider this case. In this case, we have count is equal to 0, count plus plus, return count. So in the main function, it is printing the function 1 function, and again it is printing function. So in the first case, count is equal to 0, count plus plus, so it will be incremented, and count will be 1. That is, the value here will be 1. And in the second statement we have percentage d fun again, count will become 0, then count plus plus which will become 1, and we will get 1. So finally the output for this program is 1 1. But in the case of this function, as we have started here, the lifetime of that variable is through the entire program. That is, if we are running printf percentage d fun, the value of count initially is 0, and it will be incremented by 1, so it will become 1, and after that, um, the value of count, this this statement will be only run once. After that, it will not be run again, and the value of count will be incremented by 1. So in this case, after this, printf percentage d fun will become, count will become 1, and count plus 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 will become 2, and we'll get 2. So the output for this program will become 1 2. So I hope you understood the difference between static variables and non-static variables in C. Features of static member, static data members class. When we declare a member of a class as static, no matter how many objects of the class are created, there is only one copy of the static member. The static member is shared by all the objects of the class. All static data is initialized to 0 when the first object is created if no other initialization is present. It is visible only inside the class scope, and its lifetime is the entire program. Static variables are all commonly used to maintain values common to entire class. Static variables are commonly used to maintain values common to the entire class. That is, when we consider a static variable inside our class, its value will not be changed, and it will be considered as a function. As we have seen in the previous topic, that is, inside a class, each of the functions are stored differently, that so that each of the objects can access it as common. Similarly, static variables can be commonly accessed by all the objects. So it has the control, all the objects has the control for that static variable. So that is the main difference between static data member in a class. So what is the declaration? The declaration for that is, we need to give a static in front of the variable declaration. Like member functions, they are declared inside the class and defined outside the class. So here we have a class item, and here we have static int t, and outside the class we are giving it a value, and this symbol is the scope resolution operator, which is used to access the value inside the class. So int item is the class, and inside that we are going into t and giving it a value of 10. The type and the scope of each static member variable must be defined outside the class definition. This is necessary because the static data members are stored separately rather than as a part of an object. Okay, so this is very important. That is, the type and the scope of each static member variable must be defined outside the class definition. This is necessary because static data members are stored separately rather than as a part of an object. So we have another program here, which here we have a class item, and inside here we have a static int count. So this is a static data member, and we have int number. Then we have a public, inside which we have a function 0 where number is equal to 0. Then we have get count where we have plus plus count and plus plus number, and we need to it prints out the value of count and value of number. And after that we have the value of count to be equal to 5. So here we have the main function where we have three objects, and a dot 0, b dot 0 and c dot 0 are called. And inside the functions here we have number is equal to 0. That means in all the cases we are initializing number to 0. After assigning data, then we have a dot get count, b dot get count and c dot get count. A dot get count, we have plus plus count and plus plus number. That means initially the value of count is equal to 5. Here will the count will be incremented to 6, and plus plus number will be incremented to 1. So and it is printed out, so we will get 6 1 here. Then we have b dot get count, but the value of count will become 6 and the number will still be 0 because this is not a static data member, but count is a static data member. So I hope you understood what the output of this program will be. Then we have static member functions. A member function that is declared static has the following properties. Static member functions are the functions which are static. A static function can have only access to static members declared in the same class. So what it is saying is that we can't just the static member static function cannot just access any of the variable or members inside the class. It can only access to other static members. A public static member function can be called using the class name as follows. Class name, function name, args if any, but can also be invoked using the objects as usual. Obj.function name, args if any. A member function is made static by adding the keyword static to the definition. So here we have the output. We need to predict the output. So here we have class beta, then we have private static int c, then public we have static word count c++, static word display value of c, then we have beta c, then we have the values here. Okay, so I hope you understood what the answer will be in this case too, because here we have a stat function and here we have a static variable. So that is why we can only access the static variable here, and it cannot access anything else. Similarly, we have static word count. This too can only access static in C. It cannot access any other. Static word count can access this display function because both of them are static. Now, what is an array of objects? So as you can see here, we have the class player, and then we have C5. That means we have got objects from C0 to C4. So it will be easier if we are using arrays for objects, because if we are having a lot of objects, then arrays can be used. Consider an example of a class of 50 students. So we can use arrays so that we can easily store them and manage. Now what is a constant member function? If a member function does not alter any data in the class, we may declare it as a constant member function. So as you can see here, we have a function add, and next to that we have const return. So what it means is that it will not alter any data in the class. So here we have c is equal to a plus b. but C is the data in class, so it cannot alter any data in that, so this is invalid. But we have C, a plus b. A plus b is not a data in class, it is a parameter of the function, so it is valid. So we have a dot add by some. So we have a question here. Which one of the following is true? So static methods can be overloaded. Data members can only be accessed by static methods. Non-static data members can be accessed by static methods. The D option is static methods can only access static members. So the answer here will be what? Pause the video for a minute and think about the answer. So, the answer for this question will be the static data members can only be accessed by static methods. We have a program here which is class. Here we have class which is player, and we have private int id, and we have static data member which is static int state. Then we have a public inside which we have got a function. Then we have got another function. Then we declare or we give in the values for the static data member. Then we need to print out the values. So I hope you have understood the static means. So I think it will be easier for you. So pause the video and do it and tell me the answer in the comments. So that is all for today's video. I hope you understood what I taught you today. So in tomorrow's video we will be talking more about hooks. So thank you for watching. Goodbye.